South Korea is demanding clarity from Japan on a reported plan to discharge contaminated water from the Fukushima nuclear plant into the Pacific Ocean. Seoul summoned a Japanese diplomat to request an official response. He said Tokyo will explain its disposal plan not only to South Korea but also the international community. And an expert joins us now to share his thoughts on this subject. Neil Hyatt is a professor of radioactive waste management at Sheffield University. Thanks for joining us. Firstly, what are the key issues when it comes to disposing of contaminated water?
That's a good question. So let me explain to you how this contaminated water comes about to give you an idea. The damaged reactor cores at Fukushima are continually cooled by water to maintain them in a safe condition. And as the water passes over the spent fuel and the fuel debris, it becomes radioactive. That radioactivity is removed from the water by a kind of chemical sponge and ion exchange material. But this leaves one radionuclide which it's not possible to capture, called tritium. And so as a result, what's accumulated at the Fukushima site is 1 million tons of processed decontaminated water that contains this radionuclide tritium. And that's stored in about 1,000 tanks with 150 tons of treated water added each day. And space is running out to contain that water. So the storage capacity is expected to reach full occupation in about 3 years' time. So one of the concerns is that with the storage of such radioactive water above ground, if there's another earthquake or tsunami, then if the containment of that water is lost, it will spread out and contaminate a significant area of land.
So help us understand then, dumping contaminated water from a nuclear reactor into the ocean doesn't sound good, but can you clarify just how harmful this actually is, or does it sound worse than it really is? Because after all, you did mention that it was decontaminated water.
That's right. So tritium is the remaining radionuclide in this water, and it has the chemistry of hydrogen. It's a heavier isotope of hydrogen. And so it can substitute for hydrogen in water molecules, and that makes it very difficult to extract and concentrate and therefore treat. So typically in nuclear reactors and nuclear facilities, when tritium is produced, it's diluted by discharge into the marine environment, into oceans. And we rely on the fact that there's a huge volume of water in the world's oceans to dilute the tritium to a level at which it will no longer pose a threat to human health or any other hazard.
So then with the Fukushima nuclear plant set to run out of storage space, you mentioned 3 years, about mid-2022, what sort of options are on the table then?
So really the only option on the table is discharge to the marine environment. So there are other possibilities for managing this tritiated water. One is that it could be evaporated. The other is that it could be injected deep underground. But really, discharge to the ocean very slowly over several years is the best way to dilute and dispose of this remaining contaminated water.
What about the impact, perhaps, to marine life?
So if, as I've said, the discharge occurs over several years, and it's monitored effectively, and the fish and the marine organisms are tested for uptake of tritium and other radionuclides that might be being released through the ground, discharged from Fukushima, then we can certify that this fish is, for example, safe to eat. So that's a monitoring process which is already ongoing in fish caught in the Fukushima area. And so if that process is robust and independently verified, there's no reason to be concerned about the consumption of foodstuffs under the scenario of ocean discharge.
But Neil, you know, 8 years on, Japan is still grappling with this fallout from this Fukushima disaster. Do you think a resolution is actually in sight, though?
So it's going to take a long time. It will take several decades to fully decommission the Fukushima site and deal with the on-site hazards of the partially melted down reactor cores, for example. Now, the government set in process a very ambitious timetable to achieve that. and to develop the new technologies, which will be one-of-a-kind, first-of-a-kind technologies developed for this process. Alongside that, it's investing significantly in research to develop these technologies, both in Japan and in collaboration with international organizations such as the University of Sheffield here in the UK. So, for example, we're working with colleagues in Japan to treat some of the radioactive sludges on the Fukushima site, and also to understand how the degraded nuclear fuel and the fuel debris from the meltdown of the nuclear reactors is evolving inside the reactor containments. So there's a long way to go, but the research is being done to develop the technologies to ensure that we can decommission Fukushima safely over the timescale of the next few decades.
All right, thank you very much for helping us understand this better. We've been speaking with Professor Neil Hyatt from Sheffield University.